Boom! Yes, folks, Hume here. How are you going? How are you going? So we continue with our series on trigonometry. In this video, we're going to move from the generic theta and phi to particular numbers, right? Generally in mathematics, what you find happening is that a lot of people get lost in the abstract. So when you're talking about x and y and z and p and q and theta and phi and all them kind of things, most people will get lost. A lot of people get lost there. And that is fine. Everybody's mind works differently. Good? However, the next phase, the next stage in terms of explaining stuff is to use examples. And that is where a lot of people who would have been lost at the stage of generic, they start to, their mind open and they say, oh, that is what it is, right? So as soon as you give concrete numbers, 5, 6, 7, 8, 10, 25, 30, 100, right? 1,000, 65, 64, yeah, suddenly it's at a hit home now and it's like, yeah, I'm getting it now. That is what we're going to do in this video. So now we move from theta and phi, and look at the nice numbers we're using now. 30, 60, and 90, right? This is one of the classic right angle triangles. This is commonly referred to as this is commonly referred to as the 30, 60, 90 triangle, which you could also refer to as a 1, 2, 3 right angle triangle. This, of course, being the ratio of the angles, not the lengths of the sides, right? 30 by 2 is 60. This is your 30. 30 by 2 is 60. 30 by 3 is 90. So you have a 1, 2, 3 right angle triangle, and we'll do our next one coming up. But I want to use this one to explain certain things. So in this classic right angle triangle, right, we're going to use the label up here, 30, 60, 90, or a 1, 2, 3. That is a 1, 2, 3 triangle. In that triangle, one angle is 30, one angle is 60 degrees. Of course, you would see that these two angles conform to the relation that theta plus phi is equal to 90 degrees. It doesn't matter which one you make theta. If 30 is theta, then phi is 60. If 60 is theta, then phi is 30. Once you get to the stage of doing calculations, the lettering is really not that important. The lettering is just a means to an end. Good? So, the first thing we need to do is start off with certain basic knowledge. Now, it is known that, watch it now, the sine of 30 is a half. That's something you know. You don't have to prove that. You don't have to justify that. You don't have to explain that. That is just something that is. In other words, there would have been somebody who would have been the first person at some point in history to discover that. They didn't make it, they didn't create it. They discovered that sine of 30 is equal to a half. What does that mean? Remember from your SOHCAHTOA that your sine is, your SOHCAHTOA, the SO, is opposite over hypotenuse. If this is your reference angle here, then this is your opposite side. So if the ratio, note carefully, if the ratio is 1 over 2, then if this side is 1, then I know that that side is 2. Yes? So we know that the sine of 30 is equal to a half. If you're not sure, check your calculator. If you're not sure, Google it. If you're not sure, go on whatever app you need to go on, wherever, and it wouldn't change. You could check it in a different language if you want. The sine of 30 is a half. Just accept it. Don't try to prove anything to anybody. That is what it is. Alright? Let me just pick up this here. And we go in. So if the sine of 30 is a half, right? Then what is the cosine of 60? Yeah? Watch your magic now. Now, let me, sorry, before I do that. In fact, here what I would, before we go to that point, I'm going to now invoke Pythagoras' theorem. Remember, I would have mentioned, I think I would have mentioned in the very first video on Pythagoras theorem, that Pythagoras theorem and trigonometry goes together. You can't separate the two. Alright? So if I know that the sine of 30 is a half, then by using Pythagoras theorem, I could find the length of the third side. So in other words, just let me write it up before we go to the calculation. The sine of 30 degrees is equal to right, opposite over hypotenuse, which is equal to BC over AC, which is equal to a half. It means then that if this side is 1, then this side must be 2. That is what the ratio means. It means that if this side is 2, then this side is 4. It means that if this side is 5, then this side is 10. If this side is 100, this side is 200. If this side is 64, this side is 128. If this side is 1.5, this side is 3. If this side is 2.5, this side is 5, etc., etc., etc. So in other words, the concept of the ratio, the actual length is not important. The only thing that matters is that whatever the length of this side is, you know that this side is twice this side. Yeah? That is what we mean when we say the ratio of the opposite side to the hypotenuse is 1 over 2. Or we could flip the script. It means that whatever the length of this side is, this side of course being hypotenuse, then this side, which is the opposite side, would be half. So if this side is 50, this side is 25. If this side is 100, this side is 50. If this side is 250, this side is 125. If this side is 68, this side is 34, etc., etc., etc. Alright, so I want to drive home the point again. The key here is not the actual length of the side. The key is the ratio. And using the ratio, you could then derive other important information about the right angle triangle. So now that we have this under control, where we use the sine that we know that the sine of 30 is a half, right? We just started with something that is already established, and we're using that to build out to get other things. It means then that we could get Pythagoras theorem and use it to find the length of this side. So we know that Pythagoras theorem says what? It says that, right, and I'm going to go general first, right, just as an example of how you would want to lay out your working. So by Pythagoras theorem, you would say that AC squared, which is the hypotenuse, is equal to AB squared plus BC squared. Alright, you can write it if you want as hypotenuse squared. Sorry, I should have written that first. Yes, just to keep with the convention. So you start off by saying that the hypotenuse squared is equal to the opposite squared over the adjacent squared. That is your classic Pythagoras theorem. In this particular triangle where 30 degrees is a reference angle, the hypotenuse is AC, which is, let me go general still, AC squared is equal to opposite side, BC. BC squared plus AB squared. Yeah? Now we could start to substitute values because we have the values. So AC is 2, 2 squared is equal to BC squared is 1 squared, and AB squared is just AB squared. Alright? So we have actual values here now. So we continue with the working. 2 squared is still 4. 1 squared is 1 plus AB squared. 4 minus 1. 4 minus 1 is equal to AB squared. So 3 is equal to AB squared. Therefore, keep some space here now. AB is equal to the square root of 3, which is equal to 1.732 something something something. So using Pythagoras theorem, we get that the length of AB is the square root of 3, alright, which we could also write as 1.73. We write it to 3 significant figures. Now of course, the people who do add maths will leave it in this form, which is what we refer to as the surd form. And the people doing maths will more than likely use the decimal form. So for the sake of appealing to the broader cross-section of people who are doing maths, in these examples I will go with the decimal form, alright, and we will leave the root 3 for add maths. We have things coming for the add maths too, right? So check my online platform. We have that coming. We will announce that when we're ready to start. So if you're doing add maths or you know anybody who's doing add maths, check it out, make a note of it, talk to the people, spread the word. Right, so we take out the root 3 for now, right? So the square root of 3 is 1.73, etc., etc., etc. So in other words, now we have the lengths of all 3 sides, and this therefore is your first example, doing it with me of course, where you would see Pythagoras theorem and the trigonometry merging and coming together. And that is something that will keep happening all the time. Very often in exams you will get questions where you had to deal with the two of them at the same time. So you get a diagram and you had to use Pythagoras theorem for something, and then you have to use trigonometry for something else. Yeah, but of course we will do the examples for that, not out here for everybody to see. You come in the online platform and we'll do examples, some of the harder questions. So in other words, the information is free, right, where my thing is concerned, right? It doesn't make sense trying to hide the information because it is out there. The information is free. However, there's a certain way in which we will do this thing. There's a certain way in which we'll go about this thing, right? It wouldn't always be easy. It wouldn't always be fun and games. But I could almost certainly promise you, if you stay with it and you give it a certain amount of time and attention, you wouldn't have to worry about the results. Alright? So now that we have this, we could write out all the ratios now. So we start off with sine equal to a half. It means then that we could say then that the cosine of 30 degrees is equal to adjacent over hypotenuse. Alright? 1.73. Let me write the ratios first. Adjacent over hypotenuse, which is AB over AC, which is equal to 1.73 over 2, which is equal to 0.866. Again, to 3 significant figures. Good. And then of course we could say that the tangent of 30 degrees will be equal to opposite over adjacent. The tan of that will be opposite over adjacent, which will be BC over AB, which will be 1 over 1.73, which will be equal to 0.577. Yeah? Let me just check the calculator and make sure. Yeah, the calculator here. Yeah, these are just numbers that I remember now from back whenever I was doing this thing. So 1 divided by 1.73 is equal to 0.578. Well, it's 0.577, but something after the 7. So here what? Let me do the full thing. 1 divided by the square root of 3 is equal to 0.5773. Yeah, and that is what I know. Right, so 0.577 to 3 significant figures, end of discussion. So this is what happens in the case of 30 degrees. So because this thing going on a little longer than we expected, I'm going to stop this video here and we're going to do the same thing here for 60 degrees. And then we move on to a different triangle. So stay in the game. It's a little long, but it is not always possible to abbreviate stuff. Sometimes you just have to take it as it is. Yeah? So look out for the next video coming your way.